So here's a problem that can be a bit challenging at first glance. Our exercise 4 in this section. Find the coordinates of the point on a circle of radius 12 that correspond to an angle of 5 pi over 3 radians. Now, what we mean here is we're in a coordinate system, and we mean a circle centered at the origin of radius 12. I'm going to try to draw that here. And so it's radius 12, so 12, a little lopsided, but well, this will do. And that correspond to an angle of 5 pi over 3 radians. So I have to draw 5 pi over 3 in standard position. Now let's think a little bit about that. It's a multiple of pi over 3, which we know is 60 degrees. So if we think of those multiples of 60 degrees, it's like 60, 120, 180, 240, 300, 360. So we can separate the circle, think of it as a pizza in 6 slices, right? And each slice is pi over 3. So we got 1 pi over 3, 2 pi over 3, 3 pi over 3 is 180, 4 pi over 3, 5 pi over 3. This is just meant to help us see that 5 pi over 3 is going to have its terminal side in quadrant 4. And so here's our angle 5 pi over 3. So we're in quadrant 4, and we're trying to, even though my picture is a little lopsided, we're trying to find the x and y coordinates of that point of intersection. Now we know this circle has radius 12, right? And we are going to make use of these formulas. We have our sine, cosine formula, because the sine and cosine both involve the x and y coordinates of this point. But we're going to use this in a slightly different way here. We want to find x and y. We're not plugging them in. What we're going to plug in is we're actually going to find values of sine theta and cosine theta first, and then work back to determine what the x and y values have to be. So what we're going to do is first find sine of 5 pi over 3 and cosine of 5 pi over 3. Now, in order to find the sine and cosine of these two, I need a reference angle. My reference angle is right here, and I think you can see that's pi over 3. That's another copy of 60 degrees. So maybe I'll write up above, the reference angle is pi over 3. And in quadrant 4, now let's think about what our coordinates are going to be. In quadrant 4, x's are positive, y's are negative. So x is telling me about cosine, y is telling me about sine. So the sine of 5 pi over 3 is going to be related to the sine of its reference angle, which is pi over 3, plus or minus. So here I won't write the plus or minus sign. I'm going to go right to the sign I want. I know because I'm in quadrant 4, sine is negative. So I use negative sine pi over 3. And that's negative. Now, sine of pi over 3, we got memorized. That's negative the square root of 3 over 2, right? Again, that's one of our memorized values of the trig function. And cosine of 5 pi over 3 is actually going to be, well, cosine corresponds to x coordinates. Those are positive in quadrant 4, so I want to use plus the cosine of pi over 3. And so that's going to be positive a half, because the cosine of pi over 3 is a half. Okay, so I got the sine and cosine down. Again, these signs, plus or minus signs here, were determined by the quadrant information. And next, this up a bit, we're going to use sine theta is y over r, cosine theta is x over r. Make sure you get the y goes with cosine, x goes with, the y goes with sine, the x goes with cosine. Try to be sure to keep those straight, right? And so again, that's from our other yellow card, our definition of the trig functions based on a circle of radius r. And what we're going to do now is we can plug in, we're going to say sine of 5 pi over 3 is y over the radius value is 12. We have a value we can plug in. The cosine of 5 pi over 3 is the x coordinate over 12. So we're trying to come up now with the x and y coordinates of this point where the terminal side crosses that circle. Sine of 5 pi over 3 I can replace with negative square root of 3 over 2. We just calculated that is equal to y over 12. Cosine of 5 pi over 3 we just calculated is positive a half. That's got to equal x over 12. So again, we're working backwards through these formulas. We're plugging in values for sine theta, cosine theta, and also r. And now we can solve for y and x. That's what we're going to do here. So we have these little equations we can just solve, and then we'll have our point. Multiply both sides by 12. I think I got 12 over 1 times negative square root of 3 over 2 is going to be y. 12 over 1 times a half is going to be x. And we can cancel a little bit here. I think I'm going to, when I cancel by 2, I get negative 6 radical 3 is y. And here when I cancel the 2's, I get 6 is equal to x. So the point, really we want the point xy, let's write x first, is 6 comma negative 6 radical 3. That's what we were after. So back in our picture, we just found out that the coordinates of this point on the circle are 6 comma negative 6 radical 3. Of course, x is positive, y is negative.